Good afternoon. Today we are starting also, we will finalize chapter 5 by solving some extra examples related to the water distribution. Now, we say that we have the type of connection between the pipes, either it will be parallel or it will be in series. Means what? Means what will be the difference between a shape like this, a connection like this is called parallel. Why it's parallel? Because the pipes are look like this one. This is one pipe. This is AB. This is another pipe. This is another pipe. These three pipes are connected together in a point, and they will leave the flow in another point. And that's the parallel connection. What's the property of the parallel connection? As we say that we have the head loss through this pipe, whole four pipe, from A to B, and which is its length will be 2,000 meter. It will be the same head loss that we will have from A to B, but within this line, another line, and it will be the same head loss within this line. So the main property of the parallel lines are we will have the same head loss through the parallel pipes. Means head loss in pipe 1 will equal to the head loss in pipe 2 will equal to the head loss in pipe 3 and so on. And what's different here, we have the Q through this pipe, which is the Q1, and the Q through this pipe is Q2, and the Q through this pipe is Q3. Means what? Excuse me, means the Q, this Q, the total Q that will enter the loop or the network will be Q1 and Q2 and Q3. That's the difference between the, this is the main properties of the parallel pipes. While we have parallel lines, like parallel pipes like this, for example, in this pipe, you can see we have three pipes, A, B, and B, C, and CD. What will be the QAB? It will be the same as QBC, and it will be the same as QCD. So it means Q total will be equal to QAB, will be equal to QBC, and will equal to QCD. This is the normal Q. The other important thing that we have for this pipe, the head loss through A to B, unlike the parallel pipe, will not be equal to the head loss from B to C, and will not equal to C for B. But the relation is that the head loss through A to D, the head loss through A to D will be equal to the summation of the whole partial head losses through the series pipes. This is called series pipes. This is the main things that we need. We are, as an engineer, we have to be, we are interested in to find the diameters of the pipes and the velocity through the pipes, and we have normal diameters, standard diameters, and we will use them in the networks, and we will check for the flow, we will check for the head loss. For the head at the points. When I have a pipe like this, it's about 2 kilometers length, so I will see what will be the pressure at point B. The pressure at point B definitely will be equal to the pressure at A minus the head loss that occurred here, and then I will check within this one, is it within the standard or not? And I will check this one, and I will check this one. And the Q here is, the Q is given to you, but in the practical life, you have to find that Q, and we say the Q will be, we will have to find that Q. We have main pipes. This is for the network, and we have lateral pipes. For the lateral pipes, you will, when you are going to design, I'm talking about the design, when you have a lateral pipes, you have to consider the Q fire for this place. For example, and I will give you a project on this. I will give you a landscape of a city. I want you to design for this area, the distribution network. So you have to consider the Q as a fire. We need to know that the Q fire will be depend on the population, and it will depend on A area. That's the national IS insurance service relation, or ISR, I think, and the other one is the national board relation, or the national board formula, ISF, the insurance service formula. This will be equal to 18, the square root of area, and C, this will be equal to square root of 0.01 P1 minus, and this 1020 P. Now, the main pipes lines also we have two things. Either we will count the Q fire as the Q maximum, I think daily, monthly, or it will be maximum Q hourly, maximum hourly demand. So it will be based on that one. Then you have to check for the velocity in the pipelines. It should be more than 0.6, and it will be less than 1. It will be velocity should be less than greater than 0.6. It will be less than 1.5 meter per second. This is the limitation that we have, and the final thing, the final demand is the pressure. The pressure on the nodes should be, or the head should be between 1 to 2 bars. When I say 1 to 2 bars, it will be 10 meters to 20 meters. This is the pressure, because head is equal to pressure divided by gamma. And you know that if I have, for example, 1 bar, it means 10 meter. The pressure will be equal to gamma, which is gamma water is 9.8 kilonewton per meter cube. Now, what will be the pressure at this point? It will be 98 kilonewton per meter square, or it's kilopascal, 98 kilopascal. Or you can say, this is if I have 1 meter, 10 meter head, or 1 meter. And so now this was a review for you, and just to have a summary on this. Now I want just to solve another couple of examples on the series and the parallel, and then we will skip this chapter and start a new chapter on the sewerage. This is another example, and I think we didn't solve it. This you can see, this is the William-Hazen equation. And by the way, the method we are using to calculate the head loss, we say that we have two methods. One is called Hazen-William, or William-Hazen formula. In this formula, we will have to calculate the head loss in the pipes, taking into consideration the C value, which is the Hazen-William coefficient, and we say the Hazen coefficient will be between 100 to 150. This is in case that we have a new pipes, less than 100 in case that we have old pipes. The Q will be in meter cube per second, the D will be in meter, and the length will be in meter. In this way, you will get the value of head losses in meter. Now, what will be if we use C as 100? You can either use this equation, or you can go to to use this nomograph. We say that this is a nomograph, and this nomograph are between the diameter Q and the diameter and S and I think velocity. And the method that we are taking the readings, you have to have two of those force, and you can get the other two ones. This will be happen, or you can use this one directly if you can C equal to 100. Otherwise, you can use another. You can use the equation only. This is if we have William-Hazen formula. There will be another formula for calculating the head loss, which is called Darcy-Weisbach equation, which is called F of L over D, and this will be V squared over 2G, or some of them are converting this will equal to F L over D, sorry, F over 2G. I think this will become Q squared. This will be pi d squared over 4 squared. I think it will be 2. This will be 2f L over G Q squared over d power 5. I think there is a pi here somewhere, pi square. Yeah, there is a pi square here. 2 over pi square. This F is the Darcy-Weisbach friction factor. It will depend on the type of flow and the roughness of the pipe, E over T, and Reynolds number. Yeah, we
don't have any pi squared, I think.
Sorry. Okay, go ahead, please.
I think it is like FL over D 4 V squared over 2G.
Yeah, this is the normal one. You mean this one? Okay, just convert V, and the V is equal to Q over A, and the A is pi d squared over 4, right? So it will be equal 4Q over pi d squared. This is the V. And the V squared will be equal to 16 Q squared pi squared d power 4. So multiplying by FL over D, this V squared would be 16Q squared over pi squared d power 4, V squared over 2G. This is what I thought. I mean, what will be happen? There will be 16. This will be 8 FL over D power 5 F over D over G. This will be d power 5. This will be Q squared, and there will be, I think here we have pi squared. So 8 pi squared G F L over D power 5 Q power 2. This is also the head loss. You can use directly the normal. Now we have in this equation, or in this example, we have the following: the Q total, the flow is going and distributed among 3 pipes: pipe 1, pipe 2, pipe 3. The head at this point is the head at this 15 meter, and the head at this point is 25. So head at B, and this is head at A. Now, means the differential for the head loss from A to B will be how much? Will be 15 minus 25 meters, which is equal to 25 meters. So each of these pipes having a head loss of 25 meters, and this is by equal for all line 1, line 2, and line 3. Now, what can I take? Because the value of C is not mentioned here, you can use C is equal to 100. Okay? Usually the normal cases that we have, the C's will not be mentioned. Otherwise, they will mention. Now, look at this normal graph. We have the length of pipe 1 is 2000, and we have the diameter in this pipe is 400. So for line 1, the length is 2000 meter, right? And the head loss is equal to 25 meter. So what will be the slope? This is called the slope, or a hydraulic gradient line slope. It will be equal to the head loss of this pipe divided by the line, which means 25 meters divided by 2000 meters. This is according to the line 1. And when it's equal to 12.5 times 10 to the minus 3. Why I wanted use it on unit less? I want to use nomograph. You have to this recording. Yeah, you have to use the slope of the lines in case you can see. This is the values of these are per 1000. So the S will be per 1000. So the 12.5, this is per 1000. Means that you can take directly that reading from this one. Per 1000, any of them will equal the same. So 12.5 will be represented here. This is 10, 11, 12, 12.5. This is the 12.5. Good. Now, I have a point. I need another point, either the diameter or the Q. I can see we don't have we have the diameter for line 1. I will say diameter of phi 1, which is equal to diameter of line 1, equal to 400 millimeters. And I will use for those two ones a nomograph. Which nomograph? William Hazen nomograph. We can use for diameter 400. Where is the 400? 400. Yeah. This is 400 millimeter, which is 40 centimeter. So this is a point. That's a point. So what will I should do? I should use connect between these. These two pipes. I will use can you see? So now here's the point that I'm looking for.
Doctor, how did you locate the head loss?
The head loss?
Yeah, it is 12.5.
With the head loss is by dividing the value of the head loss through A to B. We say that the pressure at A is 50 here, right? And the pressure is at B is 25. So the head loss between A and B is 25 meter, right? The value
Yes.
of S will be the head loss divided by the length. The head loss of this pipe divided by its length. The head loss of this pipe is 25 meters, we say. The length of this pipe is 2000 meters. That's the S. So 25 divided by 2000, it will be equal. And be aware, you need to just make it as a multiply by 10 to the power minus 3. This is what is the axis of S can read it. So it will be 25 divided by 2 will be 12.5, right? So it's 12.5 times 10 to the power minus 3. So this is the value of S. This is 10, this is 15. So it's will be equal to, yeah, I can see 10, 11, 12, 12.5. Now I have this 12.5 and I have the diameter of this pipe, which is 400 millimeters. Now it's 40 centimeters. And remember that we have in the right axis measurements will be in centimeters. Now I will extend this line to get the intersection of this line with this axis will give you the flow. And here's the flow. It's 200, it's 300, no, it's 200, 110, 20, 30, 40. It's between 30 and 40. So it's 235. The units are very important. It's liter per second, but remember this number is multiplied by what? 10 to the power minus 3. So it's 10 to the power minus 3. This is the Q. Oh, so the Q here is 12 and why it's multiplied? The flow in liter per second and the flow in the cubic meter per second. I'm sorry, this is this is the liter. This value is liter per second directly without this one. Okay, there is no 10 to the power. This is liter per second, or it's equal to 10^35 times 10 to the power minus 3 meter cube per second. Okay, now so the flow here is equal to 135 liter per second, and so the flow here is 235 liter per second. In the same way, you have to find the flow in the other two pipes. How to do that? Okay, now Q for line 1 is equal to 235 liter per second. For line 2, the length is 1,600 meters, and the diameter is 300 millimeters. Now find the S. The S for line 2 is equal to the head loss divided by L, which is 25 meter, divided by 1,600. We can say 25 divided by 1.6, which is equal to
15.625 10 to multiply by 10 to power minus 3. 15.625.
1.15, like this.
No, it is 15.6 multiplied by 10 to power minus 3.
Okay, just let me check. 25 divided by 1.6, it's 15.62. Yeah, that's 15 times 6. Now, for this value, this is the S. And also we have the diameter of line 2 is equal to 300 millimeters. Okay, 300 millimeter. From both, I can get the value of the Q for line 2 the same way. So we have 15.6 and we have 300. 15.6, this is the 15. This is 10, 11, 12, 13, 14, 15, 16, 15.6, it's somewhere here. and the other one is the diameter, which is 30 centimeter. Here is 30 centimeters, so we can connect between them by using a line. Can you see? Here is the second line. This line is passing. So how much is the Q? How much will be the flow? Here is the flow. It will be liter per second. How much is it? How much liters per second will be? This is 100. This is 110, 120, 100,
125.
20, 30, right? So 125, 125, 125 liter per second. And this will be the second flow. So the flow here is how much? 125 liter per second. Now the last part is when we have line 3, 2000 at 300 meters. Yeah. So for line 3, the length of the pipe is 2,300 meter and the diameter is 500 meters. Okay. Now, the same way I want just to find the value of S. The S is equal to head loss divided by length. The head loss is also 25 because it's a parallel pipe, and divided by 2,300 meter. So how much it will be in terms of 10 to the power minus 3?
It's 10.86 multiplied 10 to the power minus 3.
10.80.
86.
Okay, the diameter is 500, which means 50 centimeter, right? Diameter is 50 centimeter. So from nomograph, the Q is equal to, now again, 10.85, 86, 10.86. Yeah, this is 10. This is 11. So the 10 will be, this is 10, 11, 10.86. It's close to be here, right? And the diameter of the pipe is 50 centimeters. Here's the 50. Now, what will be happen? I'm just connecting between the 2 points, but be careful. Carefully. Yeah. Is everything okay? This is the pipe. Yeah. So this is for line 3, and you can see here is all we have.
400 liters per
The
second.
Q, yeah, is equal to 400 liter per second. Okay, now we have 400 liter per second. Okay. So the Q here is how much? 400 liter per second. So I want to, so the total flow, if I am going uh, to make another line, so this equivalent line, it will come with A to B. This is the Q. How much is the Q equivalent, or for the equivalent pipe? This equivalent pipe, the Q in this equivalent pipe will be, it should be equal to this, all the flow on the three other pipes. So it will be equal to 135 plus 125 plus 400. So the Q for equivalent pipe, the Q equivalent should equal to the Q of line 1 plus Q of line 2 plus Q of line 3, which is equal to 135 plus 125 plus 400,
400.
which is equal to
760.
760 liter per second.
Yes.
This is the Q. Now you have two things. Either it's asking us to find, the equivalent pipe for this volume. So you have to, either you wanna use diameter in the other, between other three diameters, or you can assume a length. For you, we have a line with 300 pipe diameters, we have a line for 400, we have a line for 500. You can, as an engineer, say that I will take the middle one as an average, or you can use any other pipe that is given to you. In this example, nothing given to you. You can assume you will use which diameter. For me, I will assume that I will use, let me take the new pipe, the equivalent pipe diameter should maybe equal to 400 millimeters. So assume I will use the diameter of the equivalent pipe will be equal to 400 millimeters. It's not 500, it's not 300, so I will take the middle one. So this is the diameter of the equivalent pipe, which is 40 centimeters. And the Q will equal to how much? 760. From those two ones, monograph, nomograph, I will find the S. So using these two values again, I'm back to the nomograph, 760 with 40. This is the 700. Oh, it's too much. It's beyond the scale. It's beyond the scale. 760. So what should I do? I will use directly the equation. So in case that you have a not in the scale, you can use the equation. Where's the equation? Here's the equation. So I have the head loss between the two equivalent pipes is 25 millimeters. So let's put it here this way. I will bring it back here. Okay, for this one, I have the head loss through the new equivalent pipe. Here's the new equivalent pipe, A and B. The Q equivalent is equal to 716 meter per second, and the diameter, the phi equivalent is equal to 400 millimeters. I use that one, and it's the same pipe. I will use C equal to 100. So 25, and this is the head at A is equal to 50. The head at B will equal 25, so the head loss is equal to 25 millimeters, will equal to the length of the pipe, the equivalent length, which I don't have it right now, times 10 to the 1067 times the C is 100, power 1.85 times how much is the Q? The Q is, be careful, this is what should be in meter cube per second. So 0.76 power 1.85 and divided by the diameter of this pipe, the one that I assumed 0.4 power 4.87. So we'll find the value of L. And then this way L is equal to 0.76 divided by 100 power 1.85 okay, divide times 10.67 divided by 0.4 power 4.87. Okay,
L is equal to 225.2 meters.
so it's 25 divided by 0.111. Okay. It's 225.2 meters. So the new equivalent pipe length will be sufficient in this. Now I can use or if you have a certain length, you will choose here is the length. If the length was given, so you have this and that and C. So if you have the length, you will use it in the equation and you will find the proper diameter to represent all the three pipes. So this is one of the methods that we are using in the design of the pipe. This called equivalent pipe method. This will be used for a limited number of the lines. Any questions?
No, sir. Thank you.
Thank you. I have another couple of examples, which is very important, by the way. You may have one of them, these examples in the final. Here we have this one. And by the way, this is QAB. I missed to tell you. And if I have this Q, for the pipe diameter, I have this network. You can see 1, 2, 3, 4, 5 pipes. I have through this pipelines, I have one of the diameters. So I want to see how much it will be the diameter of this pipe. Knowing that the head at the pressure at A, here's A, is equal to 15, and the pressure at E, HE, equal 20 meters. It means that the total head loss from this part and this part and this part is equal to 15 minus 20, which is 30 meters. And this part will also be 30. This is in those four pipes are connected together in a parallel way. This is a series, and those two ones with the other two ones are in parallel. This is also the whole loops can be represented by a pipe or represented or they are connected to this pipe in series. First of all, we have to know how much it will be the flow in this pipe. The flow in this pipe, by the way, I will use the C equal to 100. So the flow in this pipe, I have the L, AB, which is equal to 100 meters. And I have the HA, I have the diameter is 40 centimeters, and I have the Q, which is equal to 200 liter per second. Okay, so from those two ones, I can get what using,
Doctor,
yes,
excuse me, the flow in pipes AB and BC are in series, and from B to D and C to E are in
again, in series.
parallel.
No, from A to B, this is the total Q.
Yes.
Now, this 200, this is Q 200 liter per second. This 200, it will be diverted in two parts, in two Qs, Q BC and Q BD, which I don't know exactly how much it will come this way and this way. But I know the summation of both of them should be equal to 200. And later on, when we are coming to this loop, I should assume one of the flow. I should assume this 200 will maybe 100 of it come this way and 100 of it will come this way, and you should check that later. But this 100, when it's come this way, it will be the same 100 will come from C to E, because the same Q will come this way and it will go this way. The same flow would come here and it will be the same flow would come this way. Now, you need to assume one of, when we have a loop, assume one of them. And by the way, there is a Hardy-Cross method. It will let you know exactly how much it will be and how much it will go from the from B to C and how much it will have from B to D. Okay. I answered your question or what?
Doctor, I don't know still which one is in parallel, which one in series. It is a little complicated. Like from A to B is series, of course.
A to
But
B is one pipe, okay? This is one.
yes,
We have a loop. This loop, which is B, C, D, E. So this pipe with this loop are connected together with a series. This is a series pipe. Inside the loop, we have four pipes. A, B to C, and C to E are connected in series, right? B to D and D to E are connected to series. Together, they are also series. But B, D, E, and B, C, E are connected as a parallel. Okay?
got it. Thank you very much.
Okay, now, so first of all, we said that we have those two, the given is L length, and the diameter is 40, and I have the Q. So from those two ones, I will use 40 by 200. I'll get the Q. Okay, let's use this one. So I have 40 by 200. Where's the 200? This is 200 liter per second. A liter per second, and there is 40. This is the 40. Then I will use I can see how much it will be the value of S. Then the S is 789. It's
8.5.
Yeah, a little bit higher than 0.5. 8.7, right? 8.9, 8 point how much? 8.8. Okay, I will take 8.8 times 10 to the power minus 3. This will be the meter per meter. Is yeah. So this way we have the A is equal to 8.8 times 10 to the power minus 3. And you have the length, so the head loss, which is equal to the head loss divided by L, which is equal to the head from A to B divided by the L, which is equal to 1000. So this way, head loss from A to B is equal to 8.8 meters. Am I right?
Yes, sir.
Now, the head, there is a head here, HA equal to 50. Now, so the head at B is equal to the head at A minus the head loss from A to B, which is equal to 15.8, which is equal to 42.2. Okay, now I have the head here, a 42.2 meter. Why I need this one? Now I can say the pressure, the head loss from A to B, B to C, and C to E will have to be equal to, and we have the pressure here. So from out of those 400, we say that we have 200 liters per second this way. I will assume, this is assume, those 200 liters per second will go uniformly, or half of it will go this way and half of it is go to this way. And by the way, this is not usually to be occurred. So this is assumption. I will assume that the Q from the B to C will equal to 100 liter per second. This is my assumption. So the 100 liter per second go this way. Then if it's okay, then the Q for BD, it should be equal to 200 liter per second QAB minus QBC, which is equal to 100 liter per second also. Now, what will I will use? Why I'm using this one? Because I need to know how much it will be there. Get this one. The question is asking you for a diameter here. So you have to have S and Q because the diameter is one of the lines. So you have to those two ones. The Q it will be here, and the S it will be the head loss from B to E. I have to find the head loss from here to there, and I have to find the head loss from here to there, and then I will say there will be the flow, the head loss to this pipe. Now I have the head in here in this pipe at B is 42.2, and the head here is 20. So 42.2 minus 20, we have 20.2. Okay, so the head loss from B DE is equal to head at B minus head at E. Look at this one. I have this pipe, and the flow will come this way, and the flow will come this way. I will assume the Q that's coming this way is equal to 100 liter per second. This 100 liter I will go this way, and it's come here. So the head loss here, this 42.2 comes to become 20. So this 22.2 is going through this pipe and this pipe. So if I have a Q for this pipe, and I have the diameter of this pipe, I know I can find the head loss from B to D. So 42.2 meter minus 20, I get 22.2 meters. This is the head loss from BD. And this head loss, because they are in together in series, so I can find the head loss in this part, and then I will get the head loss in that part. Now, how to find the for B and D head loss in this part? I have its diameter and I have its Q. I will find the S and I will have the length here. I can find the head loss, individual head loss for this part. And I have 22.2 for all two pipes together. I can find the head loss in this pipe, which means the S. And I have the Q. So for having Q and S, I can find the diameter. This is the idea. Now, for pipe B and D. The Q, assumed Q is 100 liters per second, and the diameter is equal to 300. This is 300 millimeter. So I can find from nomograph S. So 100 by 30. Here's 100 by 30. This is 100. And this is 30. So sometimes you have to be precise. Anyway, so the S, I think the value of S is about to be 9. Yeah, it will be 9.2. It will be 9.2 times 10 to the power minus 3. So it will be 9.2 10 to the power minus 3. This is the S. So I have the S in this pipe. So the S for the B to D is 9.2 times 10 to the power minus 3. Its length is 600. So the head loss from B to D is equal to the value of S times the L, which is equal 9.2 times 10 to the power minus 3 liter, times the 600 meters. So what will be happen? It's 9.2 times 0.6. It's equal to 9.2 times 0.6. It's equal to 5.52 meters. Look at this number. 5.52, it's represent the head loss from, got this one, 5.52. This is the head loss. We know that the head loss from B DE is equal to 42.2 minus 20, which is equal to 22.2. We know that the whole line head loss is 22.2. This head loss from B, DE is equal to 22.2, which is equal to the head loss from B to D plus the head loss from D to E, right? Now this 22.2, we have the BE that's we found it is equal to 5.52, so plus the head loss from DE. Now what that means the head loss from DE will equal to 22.2 minus 5.52, which means 22.2 minus 5.52. It's equal to 16.68 meters. So 16.68 meters will be a losses through just DE, which is enough to find its S. So 16.68 is the head loss from B. Now I want to see how much it will be the value of S from B and D. D will equal to this 16.68 divided by the length of this pipe, which is 100 meters. And I want to be in terms of 10 to the 5 minus 3. So it's 16 divided by 0.8. It will be 20.85. So this is the S. I have the Q from this pipe. D will be the same Q that we have it in this pipe, because the same Q here is the same Q that will pass through this pipe. So we assume that the 100 liters per second will be here, and it will be the same 100 liters per second. So the Q will be 100 liters per second. On those two ones, I can find the diameter of the needed or the DE. And 100 by 20.85. Where's the 100? Hundred 20.85. This is the 100. Let me change the color. Shape. This is 100. So we have also 100. 20.85. Where's the S? Now we have 20. Uh, 20.85. So the S is 20. This is the S, 20.85. It will be here. So I have these 2 points, 0, 1. I will connect between them. This is will be. But somehow it should be more. I have 100. Yeah. So this way I can get the value of the diameter. Now, this is what I have to find the diameter of pipe DE, which is equal to 30,
155
1,
millimeters.
10, 20, 30, 40, 55. So 255 millimeter. Now, in this way, so this will be equal to 255 millimeter and 255 millimeters answer. This is the answer that we have to find it. And by the way, you will have to check this this one. Yeah, now this is the what is it? But my assumption is to have a cube which is 100 by 100, which somehow it's okay, but and look at the pipes here, 300 by 300, 255 by 250, it's okay. Sometimes you can have another solution. You have to use another method for this to check this assumption, which is called Hartley close method. And the last example is here, and I will leave it for you, but I will give it hints for that one. I have 3 connected pipes in series. This is pipe 1, that's pipe 2, pipe 3. What I have here is the Q, and determine the equivalent head loss and the total head at point D. I want to see how much it will be the head at D, and head loss, equivalent head loss equivalent, which is equal to head loss of AB plus head loss of BC plus head loss of CD. Remember that the pipe C is 120, so you cannot use the William-Mason nomograph. You have to use the equation, which is equal to 10.67 divided by this is the equation, 10.67. Yeah, this one. QDC L. You can use this one. Okay, for pipe 1, HF for AB, we have the length is for 2000 millimeters, 2000 meter times 10 to the 1067 divided by S, which is 120, power 1.85. Then we have the Q, which is the same Q. By the way, QAB is equal to QBC, which is equal to QCD, which is equal to 0.04 divided by power 1.85 divided by D, diameter of this pipe, which is equal to 4.4 power 4.87. This is HF for AB. HF for BC. You have to use the L of BC, which is 1000 meter times 10 to the 1067 divided by C, 120 power 1.85 times the Q is 0.04, 1.85, and divided by the diameter, which is 0.3, 4.87, and the last one, HF for CD, which is equal to the length. The length is 2000 meter times 1067 and C2020 1.85 times the 0.04 and the diameter is a point. This is 1.85. This is 0.2 or 4.87. After that, you will find for each of the values, you can use it. So let's check this one. By the way, this one, this, and this are common for all the three pipes. So we can use 10.67 divided by 120 power 1.85 and multiplied by 0.04 power 1.87. This is a common for all the pipes, and you have to find this one, and then you can say 2000 divided by 0.4 power 4.87 plus 1000. This is 0.3 4.87 plus 2000 divided by 0.2 4.87, and it will be equal to 10.67 times 0.04 power 1.85 divided by 120 power 1.85. So this is equal to 3.94 times 10 to the power minus 6. Okay, times 2000 divided by 0.4 power 4.87 plus 1000 divided by 0.3 power 4.87 plus 1000 divided by 0.2 power 4.87, and this is will be equal to 55 9 5 3 4 9.3 times 3.94 minus 6. So the result is equal to 22.05 meters. So the whole head loss from A to D, this is the head loss from A to D, is equal to 22.05. This is what is it's called equivalent head loss. If the pressure at A is 40, so if the pressure at A is head at A is equal to 40 meters, and the head loss from A to D is equal to 22.05, then how much it will be the head at D? The head at D is equal to 40 minus 22.05, which means D is equal to 40 minus 22.05, which is equal to
80 or 17.95.
17.95 meters. This is the head at D. Okay, guys? Is it clear?
Yes, sir, it is.
Okay.
Okay, I will post an assignment for you to be familiar with the how to find the pressure at the points, how to find the head losses, and if you have a network like linear, parallel, and a series, how to deal with them, and how to use the equation and the nomograph. By the way, using the nomograph is very important because you need it in the future. Okay? In this way, we can say